Look at the formula. This, the summary of what we learned so far is there. A tangential is equal to what? Alpha R. So if A tangential is alpha R, I can change this. So my equation will look like this. Minus T equal MA. Is that correct? And T, because I moved the R to this side, equal to 1/2 M R alpha. But alpha I will replace by A. What will be? A. I mean alpha I will replace by I will put it in terms of A. What will be alpha? A over R. So what will happen to this R and this R? And now I can add the two equations. If I add the two equations, what I get on this side? Equal to what? Here I have the letter M, and I will factor out A, and plus 1/2 of the capital N times the acceleration. And the acceleration will be equal to what? M over the mass plus 1/2 capital N times gravity. To understand what is the lowercase mass? The mass of the object. Yes. What is the capital N? The mass of the poly. This is just the usual symbology we will use. And gravity. Any question on the way that we solve this? Now we want to find alpha. What do? If you have A, which assuming that we have the masses, and we have gravity, we want to find, we already have the acceleration. Are you agree? So I gave the masses. We can find the acceleration. How can we find now the alpha? What is alpha? A over R. You find alpha. How can we find T? What will be the easier equation to find T? We already have T here and T here. So you can say T will be mg minus ma, one way, or T is equal to 1/2 ma, because already everything else cancels out. So you can substitute into this equation, or you can substitute into this equation, which will be mg minus ma. Either way, you can find the tension. Any question applying the Newton laws of motion when we have object and poly? Okay, let's go to study guide. In the study guide, there are two questions similar to this one. And say, a wheel, question number 5 and question number 6. One object and the poly. A wheel of radius 0.20 meter is mounted on a frictionless horizontal axis. A light cord wrapped around the wheel supports an 0.50 kilogram object, as shown in the figure. When released from rest, the object falls with a downward acceleration of 5 meters per second squared. The question: what is the moment of inertia of the wheel? Question number 6 is similar. They say they give the moment of inertia of the wheel numerically. They didn't say that if it's a disc or anything like that. They gave numerically, and they asked to find the acceleration. Is the same question we have here. These two questions are the same that I solved here. The same, right? So you have the core and you have the object, the poly and the object, and they give the moment of inertia. In the first one, they gave the acceleration, they asked for the moment of inertia. In the second one, they give the moment of inertia, they ask for the acceleration. I can ask also for alpha, angular acceleration, typical question. So, in this question, I gave the moment of inertia I said that it's a disk, and I gave everything, not numerically, like they did here. And I asked for the acceleration, the tension, and alpha. In their case, in question number 5, they gave the moment of inertia, they gave the acceleration, A, but they didn't give I. So what will be, you can do the same question, except that now you have A, but you don't have I. But it's the same idea. So do it. It's a homework. Do it. These 2 questions based on that one by yourself, just to get practice. We move to the next question, which is when we have more than one object. For example, yes?
On that one, how would you know which eyes you...
No, it's given. In one you have to find it. No, in one you have to find it. No, you won't find it using formula. You will find it using this. Where do you have I here? Where do you have? In these 2 equations, where is I? You will find it using the Newton laws. So this will be I alpha. So you will use it using the Newton laws. It's like I will find the mass. You know, now I am asking for the moment of inertia. So not necessarily always the moment of inertia will be found using a formula. They didn't say anything about the radius, they didn't say anything about the mass, so you cannot find it. Sometimes they will say, yes, it's a disk. Oh, yeah, the difference. They explicitly have to say what is rotating.